All right, so this is supposed to take 10 minutes to, okay, 10 to 20 minutes to explain what we have here. All right, so lesson 6. In lesson 6, the topic is data exploration and transformation in Azure data bricks. So by now, I believe every one of us know what a data brick is. We did that the first day, except maybe the person who was not available to attend the first day training. But for the rest of us, we had worked with data bricks. We have been able to, through data brick, create cluster, and also we've been able to launch a note, okay, a notebook. And in the notebook, we saw that there are a lot of Python py-spark command that we have there that we can actually use to run. So the way we work with the notebook in Azure Synapses is the same way we work with notebook in Databricks. Both Azure Databricks and then the Azure Synapse Analytics, they both have the Apache Spark. And we did mention that the Azure Data Brick is actually going to provide end to end. Okay, it provides end to end when it comes to support for data engineers and also machine learning. It provides end to end use of Apache Spark, okay, as a service or for an enterprise application. And then we mentioned that Databricks is actually a different company that was founded by the people who created the Apache Spark, and they created a company called Databricks. Microsoft partnered with them to host the Databricks environment on Azure. So we'll talk about Databricks again. That was part of our lesson 1, but I mean part of the module 1 course. Also, we'll look at how to read and write data, how to work with data frames in Azure Databricks, how to also work with data frame advanced method in Azure Databricks. All right, this picture gives us an understanding of what Azure Databricks is. That is, Azure Databricks is a fully managed cloud-based big data and machine learning platform. It is a fully managed cloud-based. That means it's something you cannot download on your laptop. It is provided as a service from Azure Cloud, or directly you can also have a relationship with Databricks yourself, the same way Azure has relationship with Databricks. Okay, so it's a fully managed cloud-based big data and machine learning platform that empowers developers to accelerate artificial intelligence and innovation by way of simplifying the process of building an enterprise-grade production data application. As you can see here, you've got what the data engineers need to use, and also you've got tools that the data scientists need to use. So data scientists will use the machine learning lifecycle management integration, which is built on machine learning runtime, and then optimized to run the different engine that we have here. So when we talk about end to end for big data and machine learning, we are saying that all the runtime, okay, that are required for you to run the data, big data, and to run machine learning are provided for you by Azure Databricks. If you are not using Azure Databricks, you will need to on your own install this runtime engine and integrate them with different tools that we have here. Okay, so Azure Databricks use an optimized Databricks runtime engine, which is what we have here. Optimized Databricks runtime engine. The engine has serverless pool. Serverless pool means you don't need to provide an advanced infrastructure setup. Okay. Also makes use of the optimized Apache Spark, Delta Lake, as well as the data bricks. So in the lab that we follow, you will experience working with notebooks in Azure Databricks, and you'll be able to create data frames. And this is one of the Azure Databricks aspects that we also cover in later module. So there's another module again where we'll still talk about data bricks. Okay. All right. So reading and writing data in Azure Databricks. Azure Databricks can read multiple file type. It can read CSV, it can read Packet, it can read JSON, It can read XML and many other data type. We've mentioned before, a good example of CSV is your Excel. Packet is Apache Packet, which is storing data in a tabular form with optimization in a it uses the column, okay, and also is able to compress data and also uses column rather than using rule for accessing the data or storage. Then we have JSON file, which you probably must have worked with before. JSON file is one of the framework we have under JavaScript. Then the Azure Databricks is also integrated with several other Azure services. Just as you can see here, you have the Databricks being integrated um, with your Delta Lake. You have it being integrated with Azure Factory. You have it being integrated with your Power BI, integrated with Azure Data Lake Storage, with Azure Snaps Analytics. Okay. Also, the notebook experience with notebook, you'll be able to read and write by simply writing your code in a shared notebook experience. In a notebook experience, you can write your code, you can even write your documentation in the same notebook. All you need to do is create a new cell, create a cell that will contain your documentation, and that cell can contain your code. We had worked with notebook while working with Azure Snaps yesterday. The same way is the way you work with notebook inside of Databricks. The only thing is that for Databricks, you need to first create a cluster. After creating a cluster, then you need to create a workspace and then launch your notebook from a workspace, either by providing a URL or providing a path to upload the file. Okay. Working with data frame in Azure Databricks. What do we call data frames? What are data frames? Data frame is similar um, to an Excel, so to say. We can view data frame as data in Microsoft Excel. That is a data frame. A data frame is like data in Microsoft Excel, data in CSV, data in your Packet data. So that's what a data frame is. So a data frame is like a box with square in it. It's organized data, which we could also refer to as a table of data. Your data frame is a single set of two-dimensional data that have multiple rows and columns in the data. And anytime we talk about rows and column, we all know that that is what you easily find in Excel. That is why I said data frame can be viewed as data in a Microsoft Excel, which has multiple rows and multiple columns. Each row in a data frame is a sample of data. Each column is referred to as a variable or parameter that is able to describe the kind of data that we have. So, example of the Apache Spark data frame API that we can use to read data in a single command is what we have here. You have Packet dir. That means this is going to read a Packet file. Okay, Packet is a file similar to a file in a tabular form, okay, which is optimized for column insertion and also to compress data. So you have a Packet directory, you provide the link that this is source plus it is found on Wikipedia, page count. This is just giving us a kind of how to access it. And then the page counts all DF, that is data frame. You start by declaring that as Spark. That is our Spark session and entry point is to start with Spark. After that, you can have .read. You can also bring the .read in front of Spark or you put it on a separate line. So .read means you want to call on data frame reader. And then you have .packet, then in bracket the Packet directory which you have specified up here. That means you want to return an instance of a data frame based on the directory that you have provided up. And then you can also type print page count, which is to print this one. Okay, what that will do is Python will ask to see the data type. That is what this will show us. When you say print means tell us the kind of data that we have in page count en all df. So this code uses data frame API in Apache Spark. And here we'll find the example of a data frame. The name of the data frame is page count. That means you want to use to count pages. So it's very descriptive. Page count. Okay. So page count is the name. And then when this code is created, it's followed by a mix of data frame functions in the same elements. Okay. And the functions here are the read function. Okay. Which is the dot read that we have in there. So okay, in this example also we are able to catch and have a count being performed. So in your lab you work with data frame, which you will be able to use to explore and see how data frames work. Also you can see here, okay, so you can mix data frame operations together. First you call on the name of the data frame, page counts, that's the name of the data frame, and here we can put dot catch. That means it should catch it, it should keep it. Cache is a temporal storage. Okay, it should cache it, and then also it should do a count on it as well. Okay, working with data frames advanced method in Azure Databricks. In Azure Databricks, there are a number of advanced transformation that we can perform in Azure Databricks. A lot of advanced transformation, and part of the transformation we can perform are one, date time manipulation. So when we talk about transformation, transformation is trying to perform operations, so to say, on the data that you have obtained. Data frame is collection of data, or is a way by which we bring out data from CSV, which can be an Excel sheet, from Packwords, from JSON file. When we bring in this data, okay, using Python command, the next thing we do is to transform the data. One of the ways you can transform the data is to use date time manipulation. This will enable different date time techniques that you can use across your data frame, different date time formats, okay, that you can use. In terms of date formats or date time formats, we can actually have year separate, then you talk about months. I'm sure you remember yesterday we were working with things like that, where you have the year, a folder for year, a folder for the month, a folder for the quarter, a folder for the month, a folder for, so that is example of manipulating of data, of date time. And then you can also translate your date time. So when you get a date from a file, you can divide the dates into different folders. That's an example of manipulation. Also, you can do aggregate function on the data. What are aggregate functions? Example is group by function. We have a sum function, count, average, minimum, maximum. These are functions that we probably were aware of. A group by function, we group the data based on a particular column. We group them together based on a particular column. A sum, we do the summation. A count, we just return to us the total number that we have, like the total number of rows that we have, okay, or total number of columns that we have. Then average, we do average for us, okay, minimum value, maximum to tell us the maximum value. Then the duplication of data. Also, data frame can, you can also use data frame, or in data frame you can remove duplicates by ensuring that you keep only one record. It can help to remove duplicates. So removal of duplicates using aggregate function and date time manipulation are part of the transformation that can be done on data through data frame inside of the Azure Databricks. Okay, so that somehow ends this lesson. So how do you list file in your database frame? Within a notebook, you can list a file by using this function fxli. If you have an idea of a Linux system or Linux system, in a Linux system or Linux, we normally use ls to list. So to list file, we start with percentage of fx ls, then we put the path that will list the file in our database frame. Okay, then how do you create a data frame object? To create a data frame object, you need to introduce a variable name and equate it to something like this. my data frame df, and you can equate it just like we have. If I go back to this one, okay, this is a name of a data frame, okay, and then you put equals to. So that's what this question is saying, that you just provide a variable name, and to a large extent your variable name should end with df, capital df. That shows data frame, okay. And then one of the syntax we normally use in Microsoft is to always start with a small letter, and then the next word will start with capital letter data. The next word is frame, start with capital letter f, and then you can put df. Okay, the next one says you need to find the average of sales transaction by store funds. Which of the following aggregates will you use? Which aggregate will you use to find average? We've mentioned the type of what we can use, avg. Okay, so avg is the aggregate function. So first you can specify that df means data frame. All right, so you have data frame group by, okay, group by, then you specify the name of the column, that is a store front, and then you put dot average, then completed transaction. So the to find the average of sales transaction, we can use dot avg, which is average function. Okay, so that will end our lesson 6. Okay, lesson 7. Okay, lesson 7 too is just to be taken for 15 to 20 minutes, and the lab is what will take about an hour to complete. All right, so in lesson 7, we want to talk about the injection and loading of data into data warehouse. Injection and loading of data into data warehouse. So when you talk about injection, what does it mean? We tried to explain that before. We said bringing in of data, okay, from different sources is injection. So data injection is extremely important part of data engineering, which of course involve balancing the needs of your source system, ensuring that you do not disrupt your system from doing their work they need to do. So we need to load data into data store that is part of the analytical system. So injection is a way of loading data or bringing in data into your analytical system. So in this module, we will see how we can inject data with variety of techniques, including the use of polybase and the use of copy command. So polybase command can be used, or copy command can be used to bring in data. And then from experience, the copy commands can help to speed the time of bringing in the data. So we must consider injection and loading of data as part of the key responsibility of a data engineer. All right, so in this lesson, we look at how to load data, the best practice in Azure Snaps Analytics. We also look at petabyte scale injection. Petabytes, I'm sure you remember, we have, of course, we know gigabytes, we know megabytes, we start with kilobytes, megabytes, gigabytes, okay, and from gigabytes you move to petabytes. Oh, you move to terabytes. From terabytes you move to petabytes, okay. So we will look at that as well as lesson 2. All right, so what are the best practice when it comes to loading data into Azure Snaps Analytics? We had worked with Azure Snaps Analytics yesterday through the Azure Snaps Studio. So the recommended best practice is: 1, you need to manage your source data file. You need to manage source data file, where the file is coming from. You need to manage your updates. You need to set up dedicated data loading accounts, that is account that will be used to load. You need to manage concurrent access to Azure Snaps Analytics, how many people will have access to it, okay, concurrently. You also need to implement your workload management. You also need to use either a polybase or copy command or copy activity in Azure Data Factory to actually inject the data into the Azure Snaps Analytics. How to do all of these are also available in our lab, and then the lab will also provide us some text which we can take few minutes to read before we start attempting our lab. Okay, so when we talk about petabyte scale, what do we mean by petabyte scale? We also mentioned that, yes, we mentioned yesterday that with Azure Snap Analytics, you can integrate Azure Data Factory. One of the things you can do with Azure Data Factory is to use what is called ETL. With Azure Data Factory, you can do ETL. ETL is standing for extract, okay, transform, and load. You can also do ELT. ELT is extract, load, and transform. So in before the advent of Azure, Microsoft has something called SQL Server Integration Service, which is SSIS. And this SSIS is what is used to do a lot of transformation. It's used to do loading and extraction of data. Now that Azure has come up, Microsoft has been able to improve on this and make it available in the cloud. Okay, it is not called SSIS now, it is called Azure Data Factory, which is a tool that can help with extracting, transforming, and loading of data. So if you look at this, this is similar to what we have been working with. This is what you see in your Azure Snap Studio. And under your Azure Snap Studio, you can integrate it with Azure Data Factory. And once you integrate with Azure Data Factory, you'll be able to see where you have move and transform. Okay, and from there you can click on, if you can drag this one, drag it to this space. As you drag it, you'll be able to use a kind of you'll be able to create more of this to create a workflow. You'll be able to create a workflow in order to copy data from a particular source and specify where the data should be stored. Okay, so that's also about it. So in our lab, we will see a lot of demo of how to set up copy activity in Azure Data Factory through the use of Azure Snaps pipeline. So we have a lot of that also done in the lab. You see more example there. Which data loading feature limit the number of resources a group of requests can consume in Azure Snaps? The feature that can help us to reduce number of resources that can be consumed is called a workload management. With a workload management, we can limit the number of resources that can be consumed so that there will not be issue with resource not available. Why should you split up one large file into smaller file when you are loading data into a dedicated SQL pool? You need to split because you want to take advantage of MPP. What is MPP? Massively parallel processing. That means you can distribute the different files, the large file broken down to smaller. You can distribute the smaller files to be handled by different SQL pool. Okay, in which section of Data Factory Designer Canvas will you find the copy activity? For you to find a copy activity, you need to go into Data Factory Designer Canvas. This Data Factory Designer Canvas, you access it through your Azure Snaps Studio, which we have been working with since yesterday. Azure Snaps, okay, Azure Snaps Studio. But before we can use it, we must first integrate the Azure Data Factory inside of the Azure Snap Studio. So there will be a lab that will also guide us into how we can get that done. So we can do a code-free injection. So this helps us to do code-free injection of data. That's doesn't require any transformation. So we can do code free, okay? We can do a code free data injection by using things like a data factory designer, move and transform under copy activity. Okay, that also ends this lesson. Then we move to lesson, the next one should be lesson 8. All right, the requirement in lesson 8 is also just to spend 15 to 20 minutes to explain, and then you spend about 70 to 80 minutes to actually take the lab yourself. All right, lesson 8. In lesson 8, we'll talk about how to transform data with Azure Factory or with the use of Azure Snaps pipeline. So we can transform data by using Azure Factory, and also we can use Azure Snaps pipeline. And since we've been mentioning Azure Snaps every time, it's also worthy of note that the Azure Snaps analytics contain Azure Snaps pipeline. It does not contain Azure Data Factory. However, we can integrate the Azure Data Factory into our Azure Snaps analytics through the Azure Snaps Studio, so that from one window or interface or web portal will be able to work with both the Azure Data Factory as well as the Azure Snaps pipeline in order to transform data. Okay, and then we'll look at the different recommendation that we can use to transform data, where to start from. Those are the things we'll consider under this lesson. Okay, so like I mentioned before, the first thing is to integrate. You can integrate with data, integrate your data factory in Azure Snaps, okay, through the Azure Snaps Studio. We also see how we can create a code-free transformation at scale by using Azure Data Factory or Azure Snaps pipeline. All right, so data integration. How is data integration being done by inside of your Azure? How do you do data integration? Okay, so the first thing you need to have is you need to have a link service component. The component of Azure Data Factory, the first thing is a link services. With link service is like a connection string, okay, where you define your connection information that is needed by the data factory to connect to external sources. Okay, so you can provide connection string to external sources like data lake store, like Azure Databricks. So you can provide that as part of your link service. So link service is just a way of defining the connection information that the Azure factory will require. The link services are used for two purposes. One, to represent a data store that includes but not limited to on-premise SQL server. It can be Oracle database server. It can be Azure Blob. It can also be data lake store. It can be any data store. Also, we use the link service to represent a compute resource. What is a compute resource? A compute resource is talking about the kind of the VM, the CPU that are required, the RAM that are required. So in a link service, you represent where data is stored, and you also provide the compute resources that can host the execution of any activity you want to do in Azure Data Factory. And like we mentioned, one of the key things that we do in Azure Data Factory is transformation of data, okay, using the ETL, extract, transform, and load. So we can represent our compute resource using the link service, also represents our storage, okay, or our data store resource as well. Then the next one is data set. What is data set? Data set represents data structure within a data store. When we talk about data store refers to where data is being stored. Data can be stored in CSV. Data can be stored in Parquet. Data can be stored in a relational database. Data can be stored in a non-relational database like Cosmos DB, like MongoDB. Okay, so anywhere data is stored is called data store. All right, your data set is a data structure that you have within your data store, which will simply point to or reference your data that you want to use for any activity as an input or output. So your data set is important, it's part of the important component of Azure Data Factory. All right, so with this, our link services, you can get, okay, info activities. Activities here represent a processing step in a pipeline. For example, you might use a copy activity to copy data from one data store to another data store. You can also use Hive activities. Hive is part of the things we mentioned when we talk about big data. Hive is also, okay, part of the Apache solution provided for analytics on big data by Apache. It's called Apache Hive. All right. So under activities, activities represent the processing steps that we have in our pipeline. The processing step that we have, for example, the process of copying data, we call it copy activity. You copy data from one data source to the other. You can copy data from CSV, okay, and copy it to, you can copy data from CSV like Excel or Packwords or JSON and copy it to another data store like SQL Server, like Oracle database, okay, like NoSQL database. So activity represent the process, the steps that we need to go through, and these steps can be as simple as copy activity. All right, we can also use what they call the Azure HD Insight Cluster. We can run the Hive query. You can run Hive query. We can run Azure HD Insight Cluster to transform or to analyze data after we have copied the data. So the steps to achieve the copy, the transformation, is what is called activities. After activity, okay, so activity is a step by step. After activity, you now need to have pipeline. So the activities, several activities, processes takes place in the pipeline. So the pipeline is a data factory which might have one or more pipeline. The pipeline can have one or more pipelines. A pipeline is just a logical grouping of activities. We have said this represents an activity, okay, like activity one. Activity one can be copy data. All right, activity two can be update data, insert, okay, or modify a data. Activity three can be things like filter a data. So the pipeline is a logical grouping. This is a logical grouping. Is a logical grouping of activities. A logical grouping of activities that perform a unit of work. Logical grouping of activities that perform a unit of work. Okay, logical grouping of activities that perform a unit of work. Okay, so you can have activities like we mentioned, a copy activity. You can copy data from one data store to the other. Okay, and then you can also have several other activities so that are grouped together to perform a piece of work that is called a pipeline. So apart from pipeline, you also have a trigger. What is a trigger? A trigger is one of the components that we have in our Azure Data Factory. A trigger represents the unit of processing that determines when a pipeline execution needs to be kicked off. When a particular pipeline needs to kick off, it is the trigger that will represent the unit of processing that determine when a particular pipeline execution needs to start. And when you talk about trigger, There are different types of trigger for different type of events. So depending on the event that you have here, you have different type of trigger for it. So example, you have a pipeline run trigger which will run, okay. A pipeline run trigger is an instance of a pipeline execution. It will run any instantiation by passing argument to the parameter that are defined in pipeline. So you have a parameter as well. What's a parameter? So this trigger keeps running. So the trigger runs the it runs your activity. So trigger is represent the unit of processing that determine when a pipeline execution should take place. When a particular execution of a pipeline should take place, that is determined by your trigger. So you can see, so trigger will determine when that should run. You can also use a parameter. What is a parameter? A parameter is a key value pair of read-only configuration. You define your parameters in your pipeline. The argument for your defined parameters will be passed during execution from one context that was created by your trigger or a pipeline that was executed externally. That is your parameter. Parameter is just a key value pair of read-only configuration which is defined in the pipeline. All right, you also have what they call the integration runtime. You have integration runtime. Integration runtime is referenced by the link services. This link service will reference the integration runtime, okay, and that integration runtime will help to provide the compute environment. We said the link service will contain information about your storage, okay, where your data is stored. It will also contain information, that is the connection string to your data. It will also contain information about the compute resource that you need. So there is an integration runtime, which is what this service will reference in order to provide the required compute environment. When you talk about compute environment, we're talking about your required server, you require VM, okay, with the memory, the required VM, with the RAM, with the number of CPU. So the integration runtime is what the link service used to connect to the compute or the infrastructure available to run any of the activities. Okay, you also have a control flow. What's a control flow? A control flow is another component in Azure Data Factory. This is an orchestration of pipeline activity that can include chaining activities in a sequence, chain activity using branching, defining parameters, defining your passing arguments while invoking the pipeline on demand or through a trigger. So your control flow, which is CF here, control flow is a way by which the pipeline activity is being controlled, okay, and that's what we call the orchestration of pipeline activity. And the pipeline activities involve chaining of different activities together, related activities that can perform a unit of work. All right, so with Azure Data Factory or Azure Snaps pipeline, you can do a code-free transformation at scale. We did something like this yesterday as well, where you are able to just click, and with your clicking, you create a kind of workflow. All right, so with this, we can start with the first one. Okay, specify. So always the first is always to specify your source. Where's your data coming from? Okay, apart from specifying your source, you can also do some mapping of data flow. Okay, you can map different data flow. That is, when the source is specified, the next thing can be to click on this. When you click on this one, it will give you option of what you can select from, the different data flow activities you can select from. So you can select a data flow on user ID, and here you'll be able to create, you'll be able to update the columns by specifying information like visitor ID, top products, purchases, and from here you can also create another activity again. So you can create multiple activities that forms a data flow. So the data flow allow data engineers to develop graphical data transformation logic. So this is called data flow. You can see data flow. You need to click on this so that the data flow engine can be activated. So data flow allows the data engineer to develop graphical data transformation logic. So this represents graphical, okay, data transformation logic that will move from one to the other, and it can have multiple sources. This one is one source. If you want to create another source of data to work with, we can click on this, and with that we'll create another data source. Maybe this one is getting data from okay, you can see from this picture, this one is getting data from JSON file. You can create another source that can get data from Packet, Apache Packet, that can get data from CSV, from SQL Server, and you can later join this source, the data from here, you can join it to any of these pipeline or any of these graphical data logic that we have represented. So these are graphical data logic that can be used to transform data without using any code. So the data flow mapping will bring benefit to us. What are the benefits we can get from data flow mapping? One, with data flow mapping, we can do cleansing of data, we can do transformation, we can do aggregation. It will also enable us to build resilient data flow in a code-free environment. It will enable us to focus on building the business logic. Okay, each of these are like different business logic. Also, we can make use of underlying infrastructure, which will be provisioned automatically when we need it. So we can have this data flow mapping to help us do transformation without necessarily writing any Python code or SQL code or Java code at large. Okay, revision. You are moving data from Azure Data Lake Generation 2 store to Azure Snaps Analytics. Which Azure integration runtime will you use? So the integration runtime you are going to use is just Azure. Okay, why? Because in Azure, that is through your Azure portal, you can create you can enable data lake generation 2 on a storage account. Which control activity can be used to branch an activity on a condition that evaluate to true or false? Anytime we talk about condition in programming generally, is always the what? If condition activity. That is what can control our activity. If condition activity. If a particular condition is true. For example, if visitor ID, let's say you want to perform a big data analysis on your on the on the public website. You want to look at analysis of your public website visits, or if you have maybe a web shop, you want to see analyze the data that is gotten, how many user visits, what do they check, what do they buy. So we can use different condition, like okay, if visitor ID, you can specify to analyze a particular visitor ID. I say if visitor ID, okay, is equal to this or less than this or greater than this or similar to a particular trend, then it should do a particular activity or run a particular it should do a copy or it should update another table as may deem fit. So if condition is what can control activity. Okay, what feature enables you to interact with mapping data flow transformation that you create? When you want to interact with a mapping data flow, you need to click on debug, which we can see from here. Without clicking on this data flow debug, you'll not be able to interact with your data flow. You'll not be able to interact with your mapping of data flow transformation. So we need to use debug to achieve that. Okay, that ends also lesson 8. That ends lesson 8. We can go to lesson 9 now. All right, so lesson 9 too, we have to spend just 10 to 15 minutes because there are just 5 important slides that are there. Okay, so in lesson 9, lesson 9 deals with integration of notepad, integration of data from notebook, from different notebook, integration of data from different notebook with the use of Azure Data Factory or Azure Snaps pipeline. That's what the um, lesson 9 deals with. And in this particular one, we also continue our work with the Azure Data Factory as well as the Azure Snaps Azure Snaps pipeline. So with Azure Data Factory or Azure Snaps pipeline, we can orchestrate a large scale data movement by using other data platform provided by Azure and also by using different machine learning technology. With this, we'll be able to take advantage of the capability of other Azure platform. We mentioned on the first day there are about 10 different Azure data platform. So you can integrate all the different data platform together in order to orchestrate a large scale data movement. So we'll look at that in this lesson. Some organization may already have data engineering investments in other technologies and they want to take advantage of it. So they can also integrate with the Azure Snaps Analytics through the Azure Snaps Studio. Okay, so this lesson is short just to talk about how to integrate data from notebooks with Azure Data Factory or Azure Snaps. Okay, so what are the steps available for us to achieve this integration? So to achieve the integration, we need to first create a storage account. Remember that you use your Azure portal to create a storage account. Usually you create a blob storage account and then inside of the blob storage account you specify what? Your hierarchy namespace. Remember, you specify the hierarchy namespace. You once you specify hierarchy namespace, with that you are going to be able to use your generation 2, okay, Azure Data Lake. So that is the first thing, is to create a storage account. And we have seen and we have worked with storage accounts yesterday. After creating storage account, the next step is to use the Azure Snaps pipeline. Okay, we can use the Azure Snap pipeline. That is to go into your Azure Snap Studio and begin to work from there. You click on data and from there you begin to integrate. You remember when you click on the data path, you will see workspace, you also see pipeline. Okay, you see link services and from there you can create your Azure Snap pipeline. Number 3, you create your data workflow pipeline. After that, you add a notebook to the pipeline. The step 1, 2, 3, we have done that as part of our activity before when we're doing lab 4. Add a notebook activity to the pipeline and then you set parameters and dependency conditions. These are the 5 steps we will use in the lab that is for lab 9, and that lab will probably not take us more than 1 hour. Okay, and that is just simply what this lesson is all about: the use of the different steps to be able to achieve the Azure Data Factory transformation of data, which involves the steps that we have mentioned here, 5 steps. So each of these steps, you will use it, you will take each of these steps in the lab 9 to be able to integrate data from notebooks with Azure Data Factory or Azure Snaps pipeline. All right, review questions. Which control flow settings allow you to pass arguments while you are invoking your pipeline? Parameter. With parameter, we can pass arguments. With parameter, we can pass arguments. Argument means we can decide to specify what will be used, like a filter. So we can control the flow setting by specifying parameter. There are 4 dependency conditions that link control flow activities together: success, fail, completed. The third one is skip. Okay, so the different dependency condition that can be used to link the control flow together, we can have it successful, it can be failed, it could also be completed, and it could be that we skip it, that you skip a particular dependency to move to the next flow activity. What type of parameters should you use when you have multiple pipeline where the parameter name values are identical? You can use global parameter. With a global parameter, you can have multiple pipeline with parameter name and value being identical. I'm sure you also remember, like in programming, when you talk about global variable, it's like a variable that applies to every other one, similar to a global parameter that is passing arguments which can be used by multiple pipeline without, so it means it's not going to prompt you every time for parameter because you have defined a global parameter. So it will use a global parameter as if it's a default parameter each time is a parameter is required to perform a particular activity. All right, so that's also sort of ends lesson 9. Now to lesson 10. Lesson 10. All right, so lesson 10 also required, okay, some few minutes to explain. So in lesson 10, we want to see the options available to optimize our query. We also need to understand how data warehouse developers future are being enabled. How developers who are working with data warehouse, how can they use the dedicated SQL pool which is available in Azure Snaps, okay, to be able to do their work. So that's what we are going to consider in this lesson. So in this lesson, we'll look at also things like table distribution, how indices is being used, and also how you can use things like statistics. So there will be also some questions that you may have, but as you take the lab, you also see answers to them. Also, as we move to the next and the subsequent lesson, we'll also talk more about it. So how can you optimize query performance with dedicated SQL pool? Dedicated SQL pool. How can you optimize query? Optimization of query, we said that also, I think yesterday, we said, no, 2 days ago, that index can be used, and then we try to also do an activity around that as well. So how do you optimize data warehouse query? How do you make the query to run faster? That is what it means to optimize. And we look at data warehouse developer features that are available in Azure Snaps Analytics. All right, so to optimize, in order to optimize warehouse query performance, what are the things that must be done? One, you need to understand your table distribution design. You need to understand the table distribution design, the table from where the data is coming from. You need to understand the design of the table. You also need to use indexes to improve performance. Generally, when you talk about data, one of the ways we know, even from our relational database knowledge, is that indexes can always help to improve our query performance. With index, it will be able to do a very fast search. Okay. Also, we need to know that by default, when a table is created, the table structure does not have index. By default, when a table is created in any database or any data store, okay, by default a table has no index on it. What that means is that a table is not really using any particular column to arrange all the rows. So by default a table does not have index. By default a table has no index. Okay, what a table rather has is what they call heap. What a table has is called heap. Heap means that A table will just keep adding data upon data in no particular structure. It's not going to, rearrange the data. It's just going to be adding data. So a well-designed indexing strategy can reduce the disk input and output operation and can consume less system resources, thereby improving our query performance. So worthy of note is that by default, table does not have index. So you need to create an index if you need to have a an improved query performance, or you need to be able to retrieve information quickly from your table. And of course, when you talk about index in SQL, we talk about cluster column index and non-cluster column index. So index can be based on one column. Okay, you can also base your index on more than one column, one plus. You can base your index on multiple columns as well. Okay, so index is what we use for fast search, and when we're talking about adjust nav analytics or data warehouse is actually used for massive data, and in that case you need to be able to have index on the table that you want to query. Also, we can create statistics to improve our query performance. Most of the SQL or relational database have a way of creating statistics in them. You can also improve the query performance with what is called a materialized view. What is a materialized view? A view is like a subset of one or more table. Okay, a view is like a subset or returning a query, result of a query of one or more tables. Okay, so a view can give you a subset records that is found in one or more tables. So with a materialized view is just a pre-written query. It's a query that will normally use what? For you to bring out the subsets, you will need to use things like a join condition, and not only join, you can also use things like filter. You can use join condition. You can also use filter. Filter is like talking about a where clause. Okay, so when you run a query on one or more table, and when you want to run on multiple table, you need to use join condition. Anytime you are running query on multiple database or multiple table rather, you need to specify the join condition that will be used to join the multiple tables together. So you can join multiple tables together and also filter it and put the results in a view, or pass the results into a view, or create a view by writing a query against multiple tables using join condition and also a where condition or group by condition that can help you to filter the data. So that can also help to improve performance with material. You can improve performance with materialized view. Okay, you can improve performance with materialized view as well. So with a materialized view, you can improve performance because the data within the view can be fetched without having to resolve underlying query to base table. Without resolving the underlying query to the base table, you can actually get your data from materialized view. So materialized view is like the table, the condition, the table query has been run, the result is now being kept in a materialized view. Okay, so a view is one of the objects of a database. Just like index is one of the objects of a database, a table is one of the objects of a database, a view is also one of the objects of a database. So when you create a materialized view, you can also improve performance. Also, you can use a read committed snapshot of your data consistency. Now, what do you mean by this? When you talk about read committed snapshots, okay, a snapshot is the state of data that you capture at a point in time. So that is called a snapshot. So if you have queries that is being run on a read, for example, a read only data, it means that the snapshot that has been copied can be used, because if the data you have there are data that are not being updated, it means that there's no need to run the query at the same time. To run the query again, you can always refer to the snapshots, because it's a read only. So read committed snapshot can also help for data consistency and improve our query performance. Also, you can optimize common query performance with result set caching. What is a caching? A caching is like a temporary storage. You also remember the same way we use cache, okay, for a website. That is, if a particular website is being visited, as long as there's a cache of that website, the next time you are visiting it for the second time within the same day, before you shut down your browser, it will get it for you faster. This is because there's a cache, there's a copy available. So we can use a result set cache to also improve performance. With a result set cache, it means that the query will not send information to the database directly. It will just read off the cache, and that improves performance as well. Okay, how do we understand the data warehouse developer features? What are the things that developers can do when it comes to the use of Azure Synapse Analytics? All right, so developers can have this question. You need to make it easier for us to specify a set of rows within a query set and compute a value for each role. What can be used to achieve this? Okay, Microsoft provides something called windowing future. Okay, if you have done SQL Server training, you will have learned something around windowing. Okay, windowing features are part of the features available to help developers. All right, so developers need a solution to be able to easily specify a set of rows within a query set and compute that set of rows. Okay, compute a value for each set of rows. To do that, you can use a windowing function. Okay, that will help to achieve that. An example of windowing function is count, maximum. So you have part of your windowing function, you have your aggregate function, which are maximum, minimum, sum, distinct, standard deviation. You can use variance, you can use checksum. You also have ranking function like rank, entile, dense rank, row number. You can also use, as part of your windowing function, you can use analytical function like lag. Okay, you can use lead. These are different functions that can be used. You can also use last value, percentile. You can use percentile rank. You can also use things like preceding for a role. All right, so it takes long to get basic information about the data in a large data set, as we are exploring data of a big data. These are part of challenges of developer. Developer wants to be able to specify a set of rows within the query results set and also compute the value for the each row. There is a solution, and which is the use of windowing functions. Windowing functions consist of aggregate functions, ranking functions, analytical functions, rows, and range function. All right, the other one says it takes too long to get basic information about data in a large data set, as we are exploring data in a big data set. To solve this, Microsoft also provides a solution. There's what they call approximate underscore counts distinct, that will return the approximate number of unique, not non-null value in a group. When you put approximate underscore count underscore distinct, it will help us to give us the approximate number of unique non-null, that is values that are available in a group of value, that you can get with using approximate, that is approx underscore count underscore distinct. So those are the common issues that developers have, and you can resolve it with the two solutions that are provided, that are provided here. Then the next one is looking at the questions now. Under this question says, which option enable you to keep track of queries that you execute against a dedicated SQL pool? You can keep track of your queries by creating label. Okay, when you provide a label will help you to keep track of queries that you execute against a dedicated SQL pool. Keeping track is like saving it. Okay, and you will work with label in your lab 11. Which transact SQL is used to change an isolation level? The SQL that can change isolation level is alter database. You specify the name of the database, and then you can set read committed snapshots on. Okay, we mentioned that one of the ways you can improve query performance is by using read committed snapshots. What this one means is that whatever you read, let's say you have 50, let's say you have 10 developers, okay, who are running a query against a database. Now, once the first developer, if you have 10 developers, okay, 10 developers are running query against a particular database that is provided here. The name is provided. If you have this particular thing set up front, or after you have created the database and you discover that there will be many people using the database, tens of thousands of people, including developers, users, business people, even customers, then it is better you set up alter database, provide the name of the database, set read committed snapshot on. So what this means is that if, for example, you have 10 developer, the first developer that read anything, that write a query to read from database, maybe a query like this, let's say select, let's assume the person wrote select top 100. Okay, top 100. Assume the person wrote select top 100 asterisk. What does asterisk means? Asterisk means all the column. Okay, if the person writes all of this from a particular table, okay, or from a particular data set. Now, because this is already set, what that means is that these 100 records will be kept, so that if someone else run the query, instead of the query being rerun afresh against the database, if the query is within this top 100, it will return the result faster for the second person, for the third person, than for the first person who actually run the command. Why? Because of read committed snapshot that has been set to be on. Okay, what command make use of approximate execution? Approximate execution, you can use this command select approximate counts. That is what we use to get approximate execution. So this will tell us approximate number of non-null. What is the meaning of non-null? Okay, it means it will tell us how many unique values are available, not null, unique values, not non-unique values that you have in a group. So if you want to get the unique values of non-null, what is a null? A null means there is no value provided for a particular column under a particular role. So that is null, like empty. Okay, so if you want to know approximate, what are the unique, what is the meaning of unique? Unique means the distinct values that are there. It's like saying distinct. Okay, what do you mean of distinct? If you have, for example, a record of sales, a sales record, if you have a sales record over 1 week, let us say over 1 month, you can decide to see how many, let's say a big company like maybe Alibaba, okay, Alibaba store, that is their web store, or Amazon web store, okay. If Amazon web store or Alibaba wants to find out, for example, how many customers, okay, visited my website or my web shop over 1 month. So if they're looking for how many customers, they are looking for unique. That means one customer can visit 10 times. But once you use select approximate underscore count underscore distinct from example, you can say the name of the table where the customer login details are kept. Then this will give us unique, not null values. So we can get, for example, the number of customers, okay, who log in to maybe Amazon to buy anything within 1 month. So we can, okay, how many people? What command can easily give us approximate number? That is the approximate underscore count underscore distinct that can help to achieve that. All right, and then we will take a lab that will show us how to explore compute storage option available for data engineering. And then in the lab, we are going to be using dedicated SQL pool inside of the Azure Snaps Analytics. Also, we'll be able to use different features available for developers. And we mentioned before, features like what? We're doing hyper log functions. You can use data loading best practice and also be able to optimize and improve query performance. So all the steps that have been mentioned as the steps required to improve on the all these steps, you will take a lab that will show you how to implement optimization on a data warehousing by using all of these best approach to achieve that. Okay, so that ends lesson 10. Okay, do we take our break now, and when we come back we'll start the I will take lesson 11. After that we start our lab, or what do you suggest? Do we take lesson 11 now for the next 15 minutes, and after that we'll go on our break, and when you come back from the break you spend the next 3 hours to do the lab, and I'll be available to provide the guidance. So what do we suggest? Do we take the break now, or we spend the next 10-15 minutes to go through this particular lesson 11? What do you suggest? Okay, somebody wrote something. All right, so what do you suggest? Okay, I okay. All right, so let's finish 11. Okay. All right, so lesson 11 talks about how we can analyze and optimize our data warehouse storage. In this, we are going to look at the different range of analysis and optimization techniques that we can use for data warehouse storage. Remember, the previous lesson talks about how we can optimize query. Okay, now this lesson is talking about how do we optimize the storage, the warehouse storage. How do we optimize it? The first one, that is the previous module, talks about how to optimize our query. So with this, we want to look at how do you optimize data storage, okay, of Azure Snaps dedicated SQL pool. So we'll learn how to work with data space usage, how to work with column storage details. We also see the different storage requirements that can be used for different data type. And we also look at how materialized view can also be executed in place of a complex query. You can execute a materialized view as against complex query. So we'll look at that in this lesson, and of course the lab that follows will also provide you a hands-on experience on it. So first we need to look at our skilled data storage usage. How is data storage being used? So we look at that, and then we look at understanding the different column store storage that are available and the impact of column data type. What are the impact of different data type that you use? Sometimes some people will use a data type that is just too big for what they are doing, and then that will affect the storage space. So all that we'll look at under this lesson, and then after that we will take a break, and you can then spend the rest of the day if possible to take the lab one after the other. So we also look at the impact of materialized view. Materialized view save the storage and save the query time as well. We also look at the different rules that we can use to minimize our log operations. All right, understanding skilled data and space usage. If you look at this, this is showing us a population by states in the US. I'm sure US, I think about 50 states. Am I right? Do we have 50 states in the US or 52 states? Yeah, so we have 50 states in the US. So you can see the spread of all the 50 states. Okay, start coming from the states with the lowest population till you get to states like California, Texas, and New York that's got a lot of people in there. So we need to optimize our data warehouse storage. And to do this, we need to look at what is called skilled data. When you talk about a skill data, we want to understand and determine different measure by using things like mean, median, and mode for us to be able to check for the center of a data set. So when you have this kind of a data, you can decide to use different grouping, okay, or group functions like mean, median, and mode to check, okay, what is the median? Median is like the middle of this. What is the modal, okay, or the mode? So the mode is like the highest number, and then we can find the median like the average, and then the mode. All right, so how we use the mean, median, and mode to relate to each other will give us an insight of the skewness of our data set. So this one now skewed towards the, towards this side, you can see this going down. Okay, so we can have, in terms of skewness, let me show this. Okay, okay, these are example of skewness. All right, so you can see skewness. So if you look at this example, you can say, okay, it's skewed towards the right. Okay, you can say this one skewed towards the left, is sloping towards this left side, and this one is like you have it skewed towards both left and right at the same time. Okay, so to understand this, it all depends on the kind of okay, so this one is like you have this map. Oops, apology for my drawing, not too perfect. Okay, so you can have something like this. You can have another one where you have, So this is equally skewed. This one is skewed towards the right, skewed towards the left. Okay. And then what we normally do with this is we can calculate our, we can easily see our mode, the highest value, the mode is up. And then if you look at, you can calculate your average, the median, you can have the median. Okay, you can also calculate your mean, which is average, based on these skewness. Okay, so there are two major forms of skewness: skew to the right or skew to the left. This one like this is like this, skewing to your right. Okay, if you do it the other way, if you start with this one, then you'll be talking about skewing to the left. That means it's the highest one is the, it is reducing towards the right hand side, that is skewing to the right, reducing gradually towards the left is skewing to the left side. So all of these are part of uh, the way we can work with our space. Okay, all right, so in this slide, you find that the data is unevenly distributed. It is unevenly distributed. That is, one vertex gets much data than its peer. Okay, and then also you need to understand that skew data and the space usage. A quick way to check the data skewness is actually to use a command. There is a command that can help us to do that, a function that can do that for us. It is called dbcc underscore p dw underscore show, okay, underscore show space, okay, not spaced, is space underscore space used. All right, so we can check for data skew, okay, by using this function. This function will tell us about our skewness. In order to have a reliable and a balanced performance, the rows in your distributed table should be spread evenly across all distribution. In order to monitor the table space that is used and to observe the relationship with different table distribution type, we can use this dbcc underscore pdw show space function. So this is a function that can help us to understand how skewed our data is. It's also helpful to know the number of rows and storage space that is being used for indexing, for which we have several dynamic management view to retrieve our information. So the skill data and the space usage in relation to optimization of data warehouse storage is what this slide is all about. In our lab, you will work with these D, you work with DMVS, which is the dynamic, okay. You work with the dynamic management view, you work with it in the lab, and then also see some code snippets that can help you to check for skill data and the space used by the skill data. Another way to explain this again is this. Now when you look at this, let me try to clean up all this. Okay, so when you look at this population by states, now if you have, so you have the lowest states in the US having a population of, let's assume this is maybe 1 million or 500,000 people. Now you have the highest one that is having over 38 million people. Now, where you are going to store 38 million, so you have 38 million, like 38 million roles. What does that mean? Because when you talk about population, we are talking about people. Now, if you have 38 million people in California, it means the record of the people who live in California will have the population record. We have at least 38 million records. Now, you also have people in these particular states with just 500,000 people. Now, when you talk about storage space, what determines the storage space is our what? Our data type. I'm sure you know that. What determines the storage space is the data type. Now, when you want to store number, like population number, okay, you specify things like integer. That's one of the data type we have. We have ints, we have bits or bytes. Okay, you have this one. Okay, so you also have in SQL Server, there's also another data type called money. Okay, so there are so many data type, and each of these data types that we see here all have their space storage. That is the size of data that can be stored in each of them. So if you have 38 million, that will give you like how many? One, two, three. Okay, 1, 2, 3. So this 38 million. So the data store for this will be far higher than the data store requirement for 500,000, and that is just what we are talking about, that data storage. So if you keep all this record in one table and you use the same data type for them, it means that when you get to a record of people in this particular state, you are going to be underutilizing the space, because you provided the same space for 38 million roles, the same space you provided for 500,000. It means that for people who are 500,000, 1 million, 3 million, they will not fully utilize the storage space that you have provided for them. And that is why we are talking about understanding the skewness. So when you understand this skewness, you can now decide to say, okay, we will not store everyone in the same with the same data type. We will rather distribute. We will store those ones that are maybe above 10 million, the same number of digits, we'll store them together. Those ones that their digits are the same, we'll store them together. So when you look at 38 million, this is 1, 2, 3, 4, 5, 6, 7, 8 digits that you have here. Okay, when you look at 500,000, you have just 6 digits. So you can store based on digits, and that way you will still manage space than when you provide a storage that can take 38 million, or that can take 10 digits or 8 digits for something that does not need more than 6 digits. All right, so how do we understand column store storage details and the impact of column type? Just as I was mentioning before, the column type is what determines the space that will be provisioned for the use of data, or for storing data that will be imputed in a record. So we need to maximize the number of rows in a row group. When you maximize the number of rows in a row group, that also will enhance your query performance. What is a row group? A row group is just a what? A collection of rows. A row group is a collection of rows. Okay, collection of rows that share the same feature in the data. Collection of rows that share the same feature that share the same features in the data. Okay, so that's what we call a row group. So we can maximize the number of rows in our row group. So if you have a column of data that contain US states, like we mentioned before, okay, US states like this. So if you have column of data that contain US states, a potential row group example will include that all the data beginning in the same states should belong to the same row group. An example would be create a row group for people in create a group like CA, that is California. You can create a row group that begins with W for people probably in Washington DC. So a column store index can improve our performance if our row group has over 100,000. If our row group has over 100,000 rows, 100k rows. If you have over 100,000 rows, okay, you can improve the performance of the query by using what is called a column store index. So first thing to note is to ensure that you use row group. Number two is to use the dynamic materialized view. This is dynamic materialized view. Dynamic materialized view will also help us, and we can utilize this. Okay, this is system.dm pwd underscore node underscore div underscore column underscore store underscore row underscore group underscore physical underscore this for column storage information. So if you want to get information about column storage, you need to run a command or execute a command like this, and this command will give you information about column storage. Okay. Also, we can use the smallest data type that work for our data. This is a very good practice. A very good practice as a developer. When you are developing application, ensure that your database, the data type you use the smallest data type that will work for the data. You must minimize the size of data type, okay, to shorten the row length, which will lead to a better performance. Because if you provide a data type that is more than what is required, let us look at this example now. If you have gender, okay, the common gender is usually male and female. Let's say it is male and female that are the gender that we have, okay, or allowed in a particular table. Now if you have gender as a column, the data type you declare for gender matters. So if you declare a data type like varchar, okay, let's say variable character. If you use varchar and you use, let's say, 255, if you use varchar 255 and you are only expecting male and female, now if someone else use varchar, okay, let me use this, okay. So if you look at this particular one, that is, okay, let's say VACA 7. Now, if you use a data type that is called VACA 255, that's variable character 255, it means that you are providing something as much as 255. You are providing something like 255, okay, a storage space for 255 characters. That's what this one means. A storage space of up to 255 is what we are providing for this data type. And since you know that you only have male and female, male has how many? This has 4 characters, okay, and this one has how many characters? 7 or 6? 1, 2, 3, 4, 5. Okay, it has only 6. So if you provision 6 in here, what this one means is that you are providing a storage space that will take maximum of 6 characters. This one means you are providing a storage space that will take 255. If you look at the information you want to save in there, or you expect to be saved in here, you do not need more than 6 characters. So it means this is the best way. It's the smallest data type that can work for gender is VACA 6. That's the one that can work for gender. However, if you also have your gender stored as M or as F, that means you only need what? That means this one too is too much. It's too much a data type, because this data type will also give up to 6. If you are just storing M or F for male or female, it therefore means you need something smaller than this. Then you can just use a fixed character, just use car, and say this is just car, okay, and you put 1. That means only 1 character, and that will give you just the space you need to work. So data type affects the storage space that our data will use. Okay, all right, the impact of materialized view. What is the impact of materialized view? We explained that materialized view is a query that you run on what? A query run on multiple tables, or let's say a query results, a saved query results, okay, or a stored query result from multiple tables. When you talk about multiple tables, then we are going to talk about the use of what? Join condition, and then you also talk about filtering the data that you are putting in a view. So you can create a view by storing the result of a query that is based on multiple tables with join conditions and uses filter. So when you have materialized view, it helps to reduce execution time. It will also improve the plan, okay, and then it is also of very low maintenance. It has a low maintenance. To make changes to it, all you need to do is just what? Refine your query, and that's as simple as that. Once you can refine the query and then you resave again, you have been able to maintain. So refine the query is a way of maintaining. Refine the query could mean you want to add additional column, you want to remove some column, you want to add some filter or take away some filter. Also, your materialized view is also having high availability, and also resilience as well. Okay, what are the rules for minimally log operation? What are the rules that can ensure that your log file is not just building up? Okay, how can you ensure that your log operations is not so much? One of the ways you can achieve that is by doing what they call a rollback efficiency. So the rules for minimally logged operation, one of it is rollback efficiency. All right, and then when we talk about this, we are saying we need to understand the difference between minimally log operations and fully log operations. Fully log operations and minimally log operation, what are the difference between them? Minimally log operations are only tracking extended allocations and tracking the metadata changes. It's just going to track what are the metadata changes, what are the changes that have been made. Example of metadata changes is the use of alter. You alter a table, for example, and then add a constraint. That is a metadata change. So when you want to track just your metadata changes and extended allocations of space, then you can use minimally log operations. The minimally log operations also involve only the required information to roll back a transaction after after a particular failure. You just need to roll back. And when you're talking about rollback efficiency, we have a command like rollback. Okay, you can roll back a transaction. Rollback in database is like what? To undo, roll back a transaction. Okay, you can roll back a transaction. You can roll it back to the very beginning before the commit, or you can roll back to the beginning after the last commit. You can also decide to roll back to a particular save point, so you can roll back a transaction. Much less information is tracked in your transaction log, which of course is ideal when you are using a minimally log operation. And a minimally log operation is better sized and it does not take so much space. We are talking about how do we ensure that we just don't fill our storage space. We can use minimally log operations. That is, the operations that are logged are just the operations that involve metadata changes, okay, as well as the tracking of extended allocation. Tracking, okay, extended allocation. Okay, all right. So in a rollback, the way a rollback work is the way undo work. For example, if you write SQL statements like maybe you insert, let's say you use a DML, data manipulation language, like insert to manipulate, that is to add additional record. You use like updates statements. If you use something like delete statements, or maybe you use merge, these are common DML, data manipulation language. If you use any of these, okay, and you decide to use commit, commit is an example of data transaction language or command. Now data transaction command in this case is you will commit, means that it should save it into the database permanently for you. All right, so anything you do that is a data manipulation, any of the data manipulation language that you use, as long as you have not done commit, it means that it has not been saved. So rollback, when a rollback command is issued, anything that has been done after the last commit will be rolled back. Now, rather than rolling back everything that has been done, let's say somebody has spent 3 hours doing any of these data manipulation language. When you do a rollback, it means that the whole work of 3 hours is being removed. So rather than rolling back the entire transaction, what is expected is that you create each of these DML as a transaction breakpoint, or you have a kind of a save point for each one. So when you have a save point for each one, it will be easier to roll back to a particular one. That means it will just roll back, maybe only delete, and you still have 1, 2, 3, rather than rolling back everything. Okay, and when you do a rollback or rollback transaction, it will also have a way by which it will not fully log. It will be minimally log operations. So minimally log operation saves space. Okay. Also, it is going to provide efficient inputs and outputs. And in the minimally log operations, you are tracking fewer transactions. Less tracking in transaction log is what you are going to have. So in a minimally log operations, some of the operations that you can use or that are being minimally logged are operations like insert, operations like insert and select, operations like create. Create is one of the operations that can be minimally logged. Create index. Okay, operations like alter, index, rebuild. Okay, operations like insert, select, those are the operations that can be easily, minimally logged. And once you can minimally log any operation, you have been able to save storage space or optimize storage space by so doing. All right, question: what would be the best approach to investigate the data at hand is if the data at hand is unevenly allocated? If it's not allocated properly, what can you use to check? I mentioned that before. DBCC, that's what you can use to check. DBCC, okay, underscore your PWD underscore show space use. That will show us the number of table rows that are stored in each of the distributions available. To achieve improved query performance, which one will be the best data type for storing data that contain less than 128 characters? Okay, you can see if you have less than 128, specify variable character. Now, I don't know how many of you know what is the difference between this and this one. Who can tell us? If somebody should use this data type, what is the difference between this one, if I call this one A, and this is B? The difference between them, just to save our time, is that when you talk about VACA is variable character. It means that it's not going to allocate 128 bytes for each of the column data. It will allocate from 1 up onto 128. So if what you are storing is, maybe you are storing your full address of your house. Let's say you stay on number 10, for example, number 10 Edward Street. Okay, and then you put the street in full. Okay, let's say this is in Arlington. If this is in Arlington, okay, Arlington, then let's say Texas, and then you provide the postal code. So if you count how many characters are these, including the space, 1 2 3 4 5 6 7 8 9, let's say there's a space here: 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27. Let's say there's a space: 28, then Texas 29 30 31 32 33. So this is just 33 characters. So when you use variable character 128, because you use variable character 128, it will store the data in, it will provide only 30 character storage space, because it will provide only 33 character storage space, because all of these is 33. If somebody else writes another address that is very long, let's say the address is 120 characters, it will allocate 120 character to store that address. That's variable character. It will vary the character that is assigned based on the number of characters that has been imputed or added. However, if somebody else should use car, what is the car? Car means character. This one is a fixed. This one will provide a fixed space, a fixed space, a fixed storage space, a fixed storage space allocation. That is what the car means. So it means that if somebody should write an address that has 33 character, it will provide 128 character space. So it means that there will be a waste of over 90 character space. And by the time you have 90 character space being allocated on use per role, and you are having millions of role, that will translate to terabyte, petabyte of unused storage space. So it's very important to provide the data type that is best fit for your column that you are specifying in any table. All right, the next one says, what is the benefit of materialized view? With a materialized view, okay, with a materialized view, you can reduce the time it takes to execute complex query, which has join and aggregate function. So for you to reduce the time it takes to execute complex query, you need to use materialized view. A materialized view is the results, okay, or a saved results of a query on multiple columns, which has join condition and also aggregate functions. Example again of aggregate functions are things like average, okay, things like sum, okay, things like minimum, okay, maximum. These are aggregate functions. Variance, standard deviation, they are aggregate functions. Okay, count is also another aggregate function. So when you have a saved query based on multiple columns using aggregate function, that is called the materialized view, and this also help to reduce execution time for complex query. And that is the end of lesson 11. Okay, so we can take our break now. All this review, we'll do them tomorrow. All right, so you can take the break. Or you have any question? So let's take 15 minutes break. Is that okay? Hello? All right. So let's take 15 minutes break, and then when we come back, you will start your lab. All right, so in 15 minutes time, we'll continue. So we are back. Are we all back now? Okay, so we can start the lab. Oh, yes, I can hear you. Which one? Okay, can you share your screen? Um, yes, you should start from lab 6, work your way through to lab 11. Are you sharing your screen? Oh. Simple. Just refresh. Refresh the browser. You will get it. Yeah, so simple. Just refresh the browser. Okay, log in again. Uh-uh. You can go. It's gone. Yeah, just refresh the browser. Yep. Or you start from the other side. All right. Okay. Um. Marboja. Okay, so you have to wait for me, right? Uh. Let's me. I hope it doesn't close for me. All right. So you want to continue from lesson 5, right? Okay. It's okay. It's okay. Uh. Well, lesson 6 is not here. Let me see. Oosh. Mm. Environment 3. Okay. Mm. Ah. I think you should stay at 5. Yeah, stay at 5. So maybe I should log out here and see whether you can log in there again. That's gonna be risky. Do I log off? What do you think? Because because the issue is if I did not log off, if I give you access, if anybody asks me for help, it will disrupt what you are doing. Do you understand? uh So and that will not be good. So let me. Okay, no. I've requested for a code for you, so I'm waiting for the code. So while waiting, let's cancel. All right. Yeah, share your screen so we can use your own. I will log in again for you. Yeah. Can you also try to launch another browser? Don't use the browser you used before. Yep. Oh my. This is funny. Um. No, use Firefox. Okay. Yeah, I think use Firefox first. Okay, this fine. This is fine. Chrome. Chrome is fine. Yep. Go, okay. lms.godeploy.it. LMX. Okay, just give me the control. Okay. Whew. Why are you not showing? Okay. All right, good. So you can resume. You see, yeah, it works. Yeah, still on five. We're done with five. Then yes, a different environment. It is a different environment. It is a different environment. Then you go to six. You know, when you are done with five, you just go back with your back arrow. It will tell you, do you want to save? Yeah, back arrow takes you back. Then you will now launch environment one, and from there you select six. Yes. Okay. So you can take control back. So happy for you. At least we had a workaround. You know that thing called expired. You know you have to increase your resolution. You know that. Okay. You know how to do it. Display. Right click on the desktop. Right click on the desktop. Yes. No, the black one. Inside where you have, yeah, right click there. Click on display setting. Display settings. Okay. Okay. Yeah, go up. Pick that one. Take it up to, remember we chose 1600 1.2, I think. Yeah, check that one. Okay. So the one before it then, 900. No, not the one of 900. Okay, try that. Yeah, try. Okay, it's good. All right, keep it. All right, so all the best in your lab. That's all we are doing throughout today. No more training slides for today. Tomorrow we'll complete this training slide, but the lab is all we do. So I'm here to support. You can take over your computer back. Give remotes. Okay, so I'm giving you back. You can stop sharing.